वेलकम बैक टू यूट्यूब चैनल द बिट कोड। तो लास्ट की वीडियो में हमने टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी से रिलेटेड कुछ और लूप से रिलेटेड एग्जांपल्स को कवर किए थे और साथ ही साथ हमने कुछ पैटर्न्स को भी समझा था। तो आज की इस वीडियो में हम कुछ और एग्जांपल्स को कवर करेंगे। सो लेट्स गेट स्टार्टेड। So to start with, we are going to take one example. So in this example, someone is given 100 rupees and every day one person is spending 1 rupee. So how many days or how much time it will take to consume these 100 rupees? It will take 100 days to consume 100 rupees if he is spending 1 rupee every day. That means 100 divided by 1 is equal to 100. But here comes the other person. He is spending 2 rupees every day. How much time it will take for him to consume 100 rupees? So for this person, it will take 50 days to consume 100 rupees because he is spending 2 rupees every day. So we can see that based upon the spending every day, there is an effect on time the money is going to be consumed. So similarly, in our examples, we will see the effect of control variables of the loops, how they are incremented, how they are decremented, and how they will impact the time complexities. तो लास्ट की वीडियो में हमने एडिशन एंड सब्ट्रैक्शन से रिलेटेड एग्जांपल्स को कवर किया था और हमने एडिशन एंड सब्ट्रैक्शन का कंट्रोल वेरिएबल्स के ऊपर इफेक्ट देखा था। तो आज की इस वीडियो में हम मल्टीप्लिकेशन एंड डिवीजन ऑपरेशन का इफेक्ट देखेंगे कंट्रोल वेरिएबल्स के ऊपर, because these operations which are applied on the loop control variables are affecting the time complexities of a program. So let's go to our first example. So in this question we have to find out the time complexity of this program. तो लास्ट की वीडियो में हमने एक important point notice किया था कि time complexity is independent of the number of statements written inside for loop. Time complexity is independent of the number of statements present inside loop. So in this example, the statement number 1 executes only once. So we neglect this because this is a constant time. This is our statement 2 and this is our statement 3. Here in this while loop, we see that the control variable is incremented by 10 in statement 2 and in statement 3 it is incremented by 20. So the total effect on control variables is that the variable is incremented by 30 in every iteration. So we have to find out how many times the statement 2 and 3 are being executed. So statement 2 and 3 will be executed n by 30 times. That is big O of n by 30. As per our previous learnings, we have to ignore the constants. So the time complexity will be big O of n. So the time complexity of this program is big O of n. Similarly, in this example, if we change the operation from addition to subtraction, like I equals to n, we write the while loop, n is less than 1, I is equal to I minus 10, I is equal to I minus 20. So for this loop as well, the time complexity is big O of n. So let us take some more examples related to the addition operation. So in this question, we have to find out the time complexity of this program. So we ignore the first statement because time complexity for this statement is constant. Here in this example, we see that the condition is I less than n. But in the previous example, the condition was I less than equals to n. So the ultimate time complexity for both these conditions is same. Here we have to find out the time complexity of statement 2. So we have to see how many times this statement is being executed. So we see that the control variable of the while loop is incremented by 2 every time. So the total number of executions for this will be n divided by 2. So the time complexity of this program will be big O of n by 2. We have to ignore the constants. So the ultimate time complexity is big O of n. Similarly, in this example, if we increment the control variable of the while loop by 5, then also the time complexity remains same. The total number of executions for this statement will be big O of n by 5 and ultimately it will be big O of n because we ignore the constants in our priori analysis. Okay, so let us take another example where we change the operation from addition to subtraction. So here in this example, we have two programs. This is program P1, this is program P2, and in program P1 we are using subtraction operation, in program P2 we are using addition operation. So in subtraction operation we have to start with a bigger number. So if we are starting with big value, starting with big number, we have to do subtraction. But if we are starting with smaller number in the beginning, then we have to do addition in the loops. So here n is decrementing, and here n is incrementing. The time complexity for program P1 will be, we have to ignore the time complexity of first statement, it is constant. For the second statement, the time complexity will be the total number of executions of this statement. So every time we are decrementing 1 and we are starting with I equals to n. So it will take n by 1 times to reduce I from n to 1. The time complexity will be big O of n. Similarly, for this example, we are incrementing I by 1 every time. So the time complexity for this program, for the first statement, the time complexity is constant, so we ignore it. For the second statement, the total number of executions for this statement is big O of n, which is ultimately big O of n. So the time complexity for both these program is same. So let's take another example. If in our program we are decrementing n by 10 each time, what will be the time complexity? So for this case as well, the time complexity will be big O of n. Let's take another example. If we have three statements in our program inside the while loop, one is decrementing n by 10, another is decrementing n by 20, and the third one is incrementing n by 15. So here we have to see the overall effect. So the overall effect here is n is decremented by 15 every time. So that means the time complexity will be big O of n by 15, which is ultimately big O of n. The time complexity is big O of n here. Let us go to the next example where we are incrementing the control variables using multiplication and division, and let us see how they are impacting the time complexity of the program. So in this example, we have to find the time complexity of this program. So here we see that the control variable is incremented twice every time. So for this example, we will try to understand what is happening here with the help of a value. Let us take n is equal to 16, for example. So for the first iteration, 1 is less than 16, which is true. For the second iteration, condition will be 2 less than 16, which is also true, because here we are multiplying I by 2. In the third iteration, the condition will be like 4 less than 16, which is also true. In the third iteration, the condition inside the while loop, the condition of while loop will be 8 less than 16, which is also true. In the fourth iteration, it will be 16 less than 16, which is becoming false, and it will exit from the while loop. So for n equals to 16, how many times the statement number 2 is executing? It is running 4 times. If we take the example, if we take the value of n equals to 32, it will run 5 times. So this mathematical pattern indicates that the time complexity of this program is big O of log n base 2. Here we are taking base 2 because multiplication in our program is happening by 2. So in case of addition and the subtraction operations, the time complexity was coming big O of n. And here in case of multiplication, and we will see some examples related to division as well, the time complexity is coming as big O of log n. Which is more among these? Obviously, the big O of n is more than big O of log n. So here we can say that multiplication affects more than addition and subtraction. So in this program, the condition was I less than n. If we replace I less than n with I less than equals to n, so in this case, the statement 2 will run So in this case, the statement 2 will run one more time. So the time complexity in this case will be big O of log n base 2 plus 1. We ignore the constants. Ultimately, it will be big O of log n base 2, which is same as what we have got here. So let us try to understand mathematically how we landed upon the logarithmic time complexities here. So here in this question, we will understand mathematically. We see that the control variable is multiplied by 2. Here the control variable is multiplied by 3. Initially the value of I is 1. In the first iteration, the value of I will be 2. In the second iteration, the value of I will be 2 raised to power 2. In the third iteration, the value of I will be 2 raised to power 3. So it is keep going, and after some iterations, let's suppose k iterations, the value of this will be equals to n. So if we take the log on both sides, the value of k comes out to be log n base 2. And if you see this example, I starts initially with 1. Initially the value of I is 1. In the first iteration, the value of I is 1 into 3, which is 3. In the second iteration, the value of I is again multiplied by 3, which is 3 raised to power 2. In the third iteration, the value of I will be 3 raised to power 3. And if we keep going like this, after some iterations, the value of 3 raised to power k will be equals to n. If we take log on both sides, log base 3, 3 raised to power k is equal to log n base 3. Here it will be k is equal to log n base 3. So we see that in logarithmic time complexities, the base value is same as the value with which we are multiplying or with which we are adding. So going forward in our examples, what we will do, let's suppose I is equal to 3 times I, then in those cases the time complexities will be log n base 3. We will simply put the log value as the multiplication factor. So let us take some examples related to multiplications and division. So we have to find out the time complexity of this program. So we see that there are two statements written inside for loop. So we have to see the overall effect of these two statements, which will be I is equal to 6 times I. So from our previous understanding, we can say that the time complexity of this program will be big O of log n base 6. Let us take one example related to division. So here we are starting with a big value in the beginning, I is equal to n. So we have to divide each time to reach up to 1 or less than 1. So here we have to divide each time to reduce the value of n. So here also with the same value of n is equal to 16. The process this time is reverse because we are starting with 16. Initially n is starting with 16, and in each iteration it is divided by 2. Next iteration it will be 4. Next iteration it will be 2, and in next iteration it will be 1. So if we generalize it with the value of n is divided by 2 every time, n by 2, n by 2 raised to power 2, n by 2 raised to power 3, n by 2 raised to power 4, and if we keep going after some iterations, n by 2 raised to power k will be equals to 1. So if we solve this, it will be n is equal to 2 raised to power k, and if we take log on both sides, log n base 2, log base 2, 2 raised to power k, the value of k comes out to be log n base 2. So in case of division as well, the time complexity is big O of log n base 2. So let us take another example with division. Let's try to understand. So in this example, we have to find the time complexity of this program. So we see that there are two statements written inside while loop. So we have to figure out the overall effect of these two statements. So it will be n is equal to n by 6. So from the previous example, we can say that the time complexity of this program will be big O of log n base 6. So now we see that finding the time complexities is getting more and more simpler. So let us take another example to revise one of our previous things. In previous examples, we learned that the multiplication affect more than the addition and the subtraction. Similarly, we can say the same thing for division as well. Division has the more effect than addition and subtraction. So let us take another example. So in this example, we have to find out the time complexity of this program. So we see that inside while loop, there are 4 statements written inside it. So the time complexity of this program will be the total number of executions of these statements. So we have to find out the overall effect of these statements. The first 3 statements are doing the multiplications on the control variable, and the last statement is doing the division operation on the control variable. So the effect of multiplication is I is equal to 30 times I, and division is dividing by 10. So the overall effect will be I is equal to 3 times I. The time complexity of this program will be nothing but big O of n base 3. So let us take the last example of this video, where we will generalize or derive some statements based upon all these examples, that multiplications and the division operations affect more or have higher effect on the time complexity as compared to the addition operations and the subtraction operations. So let us go to our next example. So here in this example, we have to tell which operation is having the higher effect or more effect on time complexity of a program. So we see that first operation is division, second is division, third is division, fourth is multiplication, and the last one is subtraction. So we have seen that in case of multiplications and divisions, we are getting logarithmic time complexities, but in case of addition and subtraction, we are getting big O of n time complexity. So here, if we have to find out the overall effect of all these 5 operations, then we know that multiplication and division has more effect on the time complexity. So the overall effect will be n is equal to n by 3. We will neglect here this subtraction of 10 because this is having a very low effect on the division and the multiplication. So we neglect it. The overall time complexity of this program will be big O of log n base 3. So the answer to this question is multiply and divide operations will affect more. So that's it for this video, guys. In the next video, we are going to understand the effect of power operations on the time complexities with the help of some examples. तो आपको किसी भी पार्ट के रिलेटेड कोई भी इश्यू है या फिर कोई भी डाउट आ रही है तो आप कमेंट्स में लिख के हमें बता सकते हैं. We'll clarify those doubts in the comment section. Thank you for watching this video. See you in the next video. Bye bye.